Dear students, today we will discuss about the casting process. Casting is one of the most versatile manufacturing technique. This casting technique was invented around 5000 BC to manufacture knives, coins, arrows, statues, etc. This technique was developed during the World War II and now can be able to produce castings weighing from few grams to 50 tons of any complex shapes. Largest cannon in the world situated at Jaigarh Port, Jaipur, weighing of about 50 tons. So, what exactly the definition of casting? Casting is a process of producing metal objects by pouring molten metal into the molds and allow it to solidify. The solidified object it is exactly termed as a casting, and where the place is used for manufacturing casting is exactly called it as a foundry then. So what about classification then? So foundries may be classified based on the type of metal or alloy being used for manufacturing castings. Accordingly, ferrous foundries and non-ferrous foundries. And second classification, foundries are further classified according to the nature and organizational framework then. Accordingly, so jobbing foundry, mechanized foundry, and a captive foundry then. So what are the advantages and the disadvantages of casting process then? So casting it is one of the most versatile manufacturing process. It means that capable of producing any type of complex shapes. The shapes difficult and uneconomical to obtain by other means can be able to achieve through casting process. Casting provides a greatest freedom of in terms of design, shape, size, and product quantity. Some metal that cannot be formed can be produced by casting process. Then very heavy and bulky parts which are difficult to fabricate can be cast. Casting imports unidirectional properties and better vibrational damping capacity. Casting can be designed for equal distribution of loads and for minimum stress concentration. Then controlled and mechanical and metallurgical properties can be able to obtain with the casting process. Then casting process can be mechanized and usefully employed for mass production. Then at last casting process produces machinable part. Then coming to the what disadvantages or limitations of the process then, casting process mostly deals with the elevated temperatures, mostly works with the very high temperatures more than 1350 degrees centigrade for ferrous and 700 degrees centigrade for non-ferrous metals and alloys. And second one needs many trials to stabilize the product then design of product changes, it is difficult to change or adapt then. Casting process disposes dangerous gases during solidification then casting requires a very high investment, more pore space, then very lengthy process then, poor surface finish, manpower required it is also more than, and storing of molds and cores may losing their properties for long time then, and there are limitations regarding thin sections also. Then what are the applications of casting process then? So all kind of machine tool structures, railroad equipments, pumps, valve fittings which are difficult in complexity can be able to manufacture then. Turbine vanes, aircraft jet engine blades, sanitary fittings, communication, construction and atomic energy applications, energy parts, transportation vehicles, mill housings, power generators, supercharger casings for aircrafts, agriculture parts, and all kinds of machinery parts can be able to produce them. Then some of the important terms which are related to the what typical sand casting process are flask. Then it is metal or wood frame without fixed top or bottom. Drag flask means it is a lower molding flask. Cope molding flask it is a upper molding flask. Then pattern then it is a replica of the final object to be made. The mold cavity is made with the help of pattern. Then parting line, this is the what dividing line between the two molding flasks that makes a molder. Then molding sand which binds strongly without losing its permeability to air or gases. Then it is a mixture of silica, clay and moisture in appropriate proportion. Then facings and then a small amount of carbonaceous material sprinkled on the inner surface of the mold. Then core, then a separate part of the mold, made up of sand and generally baked, and used to create intricate. Then pouring basin, a small funnel shaped cavity that is at the top of the what mold, into which the molten metal it is poured. Then sprue, then the passage through which the molten metal from the pouring basin reaches the mold cavity. In many cases it controls the flow of molten metal into the mold. Runner, then the channel through which the molten metal is carried from the sprue to the gate. Gate, then a channel through which the molten metal enters the mold cavity. Then choplet, then choplets are used to support the cores to prevent a buoyant effect from the molten metal. Then riser, then a column of molten metal placed in the mold to feed the casting as it shrinks or solidifies, also known as a feeder head. Then all these are the important terms related to the casting process. Then what are the important steps involved in making casting? Then so normally, pattern and core box making, it is the first step. Then so normally pattern, it is a replica of the part to be produced. Then so it is a typical model of the casting used to make the mold, made up of either wood, metal, or some other material. Then the mold is made by packing some readily formed sand aggregate surrounding the pattern. When the pattern is with, then it imprints a cavity in the molding sand, then that is exactly called it as a mold. Then core making, cores are placed in a mold cavity to form the interior surface of the casting. Thus the void space is filled with the molten metal and eventually it becomes the casting. Then second step, it is of molding. Then before molding, then the sand should be test and prepare to obtain the desired properties, then for making cores and mold. Then later molten metal to be prepared simultaneously beside this. Then by adding all other ingredients to obtain the desired composition of the molten metal. So once the molten metal it is ready, then that it is ready for pouring. Then so this it is poured between the cope and drag mold after assembly. Then so after that molding also we have already carried out well in advance after core making and pattern making. Then molding, it is nothing but the mold preparation activities for receiving molten metal. Usually it is a sand mass. Then so later, once the molten metal reaches a melting point, then it is to be poured into the mold through the pouring cup, runner, sprue bottom, and to the and through the ingot into the mold cavity. Once it is completely filled, the molten metal it will be comes out through the riser. So after metal comes out through the riser, then so you have to stop the pouring. Then later it is allowed to solidify. Then after solidification, the casting is to be removed and test the casting visually. So if any defects find in the visual inspection, then all the defects are in acceptable range, it is accepted. Otherwise it will be sent back to the defective ad. Then later, then so once it is ready, then so once it is finished and cleaned, then so casting surface has to be removed by heat treatment process. So all process have been carried out earlier. Then later, then dimensional accuracy have to be checked. Then once the casting it is accepted dimensionally, then it is ready for shipping. Then all these are the steps involved in making casting. Then so however, then how to prepare mold and get it ready for pouring molten metal into the mold. Then look at the picture. Then so there is a drag mold box. Then so that is kept on the bottom board. Then so on which mold flask has to be kept, and in the mold flask the pattern has to be placed. Then molding sand, the prepared molding sand simultaneously prepared beside that has to be poured around the what pattern then, and ram thoroughly then. So once molding sand properly rammed, then after ramming, then the excess sand has to be leveled or removed by using a striker bar. Then later, then the vent holes are made in the drag to pull the depth to the what pattern, and pattern should not get damaged or mold should not get damaged. Then finished drag flask is now made upside down then. So once it is upside down, then cope pattern also assembled over the drag pattern by using double hole and double pin, and cover the what cope box, mold box over the what pattern, and lock the what both the boxes. And again we have to fill the what prepared molding sand around the top molding top pattern. Then ram thoroughly again. After proper ramming, then so excess sand has to be removed by what using a strike of rod. Then so once it is removed, then both the box has to be separated. Then remove the pattern. Then once it is removed, then the pattern, it is imprint what shape of the what pattern into the what molding sand. Then so then after what preparation of the mold, the check for the what gating elements if it is provided along with the pattern. Otherwise you have to what form these gating elements along with the what cope and drag mold manually. Then so once it is ready, then course if it is necessary to fit in the mold, then you have to fit it in the core prints of the what drag off of the mold. Then later cope has to be assembled, lock the cling or locking arrangement, then it is ready for pouring. Then so these are the what steps involved in making casting. Then so these what these detailed steps has to be carried out what obtain the sound or defect free casting. Then thank you.